right now, as we speak, there are over 15 billion connected IoT devices on the planet. Yeah, 15 billion. It's a market that's exploding past $170 billion this year alone. But what if I told you that you don't need to drop thousands of dollars on lockdown, overpriced commercial gadgets to get a piece of that future? What if your house actually knew you better than you know yourself? Picture this. Your bathroom mirror gives you a personalized daily briefing. Your front door unlocks just by looking at your face, and your desk literally yells at you when you slouch. Sounds like straight up sci-fi, right? Well, welcome to this explainer. Today, we're going hardcore DIY. We're going to dive into how you can build jaw-dropping, professional-grade home automation completely from scratch, using cheap microcontrollers and open-source software. Here's the roadmap for what we're unpacking today. First, we'll look at the 2025 IoT revolution and the brains behind the operation. Then we dive into the Magic Mirror smart display, the AI face recognition lock, and some awesome ESP32 automation for your desk and your plants. After that, we'll cover a 100% local voice hub, and finally, break down the costs and next steps. Let's get right into it.
All right, part 1, the 2025 IoT revolution, or really, the brains behind the operation.
So, to build these insane projects, you really only need to get familiar with two main hardware platforms. The whole 2025 maker revolution is basically driven by how incredibly accessible these two boards have become. First up, we have the heavyweight champion, the Raspberry Pi. Think of the Pi as a full-blown desktop computer that someone hit with a shrink ray until it was the size of a credit card. It runs a full Linux operating system, packs high-speed USB ports, HDMI out, and packs some serious processing power. That makes it your absolute go-to for heavy lifting. We're talking artificial intelligence, machine learning, or processing high-definition video. On the flip side, we have the ESP32. If the Pi's the brain, the ESP32 is the nimble little nervous system of your smart home. Guys, this thing is like a $2 ninja. It's an ultra-low power microcontroller that costs literal pocket change, but, and here's the kicker, it has built-in Wi-Fi and Bluetooth right out of the box. So it's absolutely perfect for reading sensors, flipping electrical relays, and just making sure all your gadgets talk to each other seamlessly. Which brings us to project number 1, the Magic Mirror, the smart display, your reflection powered by Node.js. This project is a total classic, and honestly, the wow factor is just off the charts. The smart mirror is exactly what it sounds like. It's a functioning mirror that magically displays bright digital widgets floating right inside the glass. So how does the illusion actually work? Well, you take a standard, cheap 22 to 32-inch LCD monitor, maybe an old one you strip out of its plastic bezel, and you hook it up to a Raspberry Pi 4 or 5. Then, you place a two-way acrylic mirror sheet directly over that screen. Here's where the magic clicks into place. When you boot up the open-source Magic Mirror 2 software, which runs on Node.js and Electron, the UI has a pure pitch-black background. Because of that dark background, the monitor essentially stays completely invisible behind the acrylic sheet. Only the bright, high-contrast white text and graphics push through the mirror. So imagine brushing your teeth while your mirror shows a crisp reflection, completely overlaid with live weather radar, your Google Calendar, your Spotify track, and maybe even an AI daily briefing running off the ChatGPT API. Plus, we use a process manager called PM2, so the whole thing just auto-starts the second you plug it in. It looks like pure sci-fi. Moving on to our second project, the AI face recognition lock. Time to ditch your keys for computer vision. Okay, imagine walking up to your room, glancing at a camera, and the door instantly clicks open. No keys, no PIN codes, no phone. To understand how we securely pull this off, we've got to geek out on the computer vision for a second. According to the fantastic documentation over at Pi Image Search, this system leverages something called deep metric learning. See, instead of training an AI to just spit out a simple yes or no when it sees a face, we use a complex neural network, specifically ResNet34 using the DLib library, to map your face onto a massive 128-dimensional graph. Yeah, 128 dimensions. It literally outputs a list of 128 real-valued numbers that perfectly quantify your unique facial structure. During training, the AI tweaks its weights so that happy you, sleep-deprived you, and just woke up you all cluster tightly together into a VIP zone on that graph. Meanwhile, your roommate's face, completely banished to the exact opposite side of the map. This highly specific clustering is how it achieves a staggering 99.38% accuracy. So the actual build process breaks down into 3 insanely satisfying phases. Step 1, you run a Python script to snap about 30 to 100 varied images of your face using a Pi camera. Step 2, you train the model using DLib to generate that highly accurate facial data file we just talked about. And step 3 is the real-time recognition. This is where you get that unbelievable demo moment. Picture this. You walk up to your bedroom door carrying a coffee and a laptop. Hands are completely full. The Pi camera mounted on the frame is continuously scanning. The split second it spots you, it calculates those 128-dimensional embeddings and matches them to your VIP profile. If the math checks out, the Raspberry Pi fires a tiny 3.3-volt signal to a relay module, and then, clack, you hear this heavy, incredibly satisfying physical snap of a 12-volt solenoid lock pulling back, and the door just drifts open. No fumbling for keys in the dark, it is pure Tony Stark vibes, and you built it entirely yourself. All right, on to Section 4, ESP32 Automation, Desk and Plants. Using sensors to monitor your posture and your greenery. Now, let's pivot away from the heavy AI lifting of the Raspberry Pi and check out the nimble, sensor-driven magic of the ESP32. Project number 3 is the ultimate smart desk. We start by hooking an ESP32 S3 dev kit up to a PIR motion sensor and an ambient light sensor. So, when you sit down and the room is naturally dark, your desk automatically fades up this slick, undermounted LED strip like a spaceship powering on. Pretty cool, right? But here is the brilliantly chaotic part. Let's be real. After an hour of coding or gaming, we all unconsciously fold ourselves into the shape of a shrimp. To fix this, we physically embed force and flex sensors right into the seat cushion of your office chair, routing the wires under the desk to the microcontroller. If that ESP32 detects that your weight distribution has shifted into a terrible, spine-destroying slouch for more than 30 seconds, it triggers a physical buzzer and aggressively flashes sit up straight on a tiny OLED display mounted right under your monitor. You are essentially building a highly intelligent desk that relentlessly nags you into having good posture. And hey, while we already have our ESP32 microcontrollers out and wired up, let's look at Project 4. This is basically the ultimate life hack for those of us who chronically murder our houseplants. The IoT plant waterer is just a beautifully simple concept. You stick an analog capacitive moisture sensor deep into the dirt of your favorite potted plant. The ESP32 constantly monitors the precise humidity levels. The exact second the soil gets dangerously dry, the microcontroller snaps a relay shut, activating a tiny 5-volt submersible water pump for just a few seconds to deliver a perfectly measured drink of water. I'm telling you, the sheer satisfaction of sitting at work, opening an MQTT dashboard on your phone, and manually triggering a water pump for your fern from miles away, it's unbeatable. It totally saves you from the cycle of overwatering and underwatering, and the whole rig costs maybe $20 to put together.
Next up, Section 5, the Local Voice Hub, Ultimate Privacy Without the Cloud.
This brings us to our 5th and final project, which tackles a massive problem in the modern tech ecosystem. Look, most commercial smart speakers basically act as constant wiretaps. They beam the audio of your living room up to corporate cloud servers just to process really simple commands, which is a massive privacy concern. Contrast that corporate tracking with the open source purity of this DIY hub. You can build a 100% offline, fully local voice assistant using a Raspberry Pi. By running open source speech recognition models like Vosk, or a localized, downloaded version of OpenAI's Whisper, your Pi listens and processes the audio entirely on the physical device sitting right there in your room. It then triggers local Python scripts that talk directly to a Home Assistant server to turn on your smart lights, flip smart plugs, or blast the AC. Your audio literally never leaves your living room network. It is the ultimate anti-corporate, perfectly private smart home setup. Finally, Section 6, Costs and Next Steps. Building your ultimate smart home on a budget. So we've talked about the incredible tech, but how accessible is this really for a weekend project? Well, a commercial smart mirror from a high-end retailer can easily cost over $1,000. But by using a spare monitor and a Raspberry Pi 4, we're building a vastly superior, highly customized version for around $115 to $165. The AI door lock and the voice hub sit right around that $60 to $100 sweet spot, mostly driven by the cost of the Pi itself and the heavy-duty hardware like the solenoid lock. But look at those ESP32 projects on the table. Because those microcontrollers are the ultimate cheat code, costing as little as $5, you can build a fully automated posture-correcting smart desk for around $45 to $55, or that automated plant watering system for under $20. You're getting hardcore, professional-grade home automation for less than the cost of a single locked-down commercial smart bulb. So, I have to ask, which of these 5 crazy IoT projects are you going to build first? Are you going to dive into computer vision and start mapping your face for the AI lock? Or are you going to fire up a soldering iron to build that nagging smart desk? When you realize that the barriers to building a sci-fi home have basically completely disappeared, the only question left is what you are going to invent next. Drop a comment down below and let me know your favorite project. Grab a Raspberry Pi or an ESP32, fire up some Python, and start tinkering. Thanks for joining me on this explainer, and I will catch you in the next one.